Good morning, everyone. Welcome to this video. Our topic for today is all about Aristotle and Galileo's concept of motion. The vertical motion, horizontal motion, and the projectile motion. First, we will tackle the vertical motion of Aristotle and Galileo. Aristotle vertical motion means vertical motion is referred to as natural motion. In a natural motion, the object will move and will return to its natural state based on the object material or composition, the earth, water, air, and fire. Here are some examples. A ball was thrown in an upward motion. As the ball was tossed upward, it will move downward into the ground, which is its natural state. Next is Galileo's vertical motion. He believes the absence of resistance object would fall not depending on their weight but in the time of fall. Also, if the object encountered a resistive force from a fluid equal or greater than its weight, it will slow down and reaches a uniform motion until it reaches the bottom and stops. Here are some examples. Two balls with different weight at the same height are dropped at the same time. We can both see that, not depending on their size, they will both hit the ground at the same time. So, the difference between Aristotle and Galileo's concept of vertical motion, in Aristotle's vertical motion, he states that all objects are thrown upward will always go down, while Galileo stated that if two objects of different weight are dropped from a height, both of them will hit the ground at the same time. And now, let's move to horizontal motion. Aristotle horizontal motion. Aristotle believes an object moving in a violent motion requires push or pull to maintain horizontal motion. Motion continues only so long as there is an applied force to an object. When the force is removed, motion stops. Here are some examples. The table will remain on the floor in its static position unless a push or pull force is applied. Galileo's horizontal motion. Galileo believes an object in motion, if unpeded, will continue to be in motion, and an external force is not necessary to maintain the motion. If the Earth's surface is very flat and extended infinitely, objects that are pushed will not be impeded. Thus, the object will continue to move. This kind of motion, however, is not evident in nature. Let's watch this example. The ball was pushed on a flat plane. If there is no friction and disturbances, the ball will continue to roll indefinitely.
Aristotle believed that the projectile motion of an object is parallel to the ground until it is the object's time to fall back into the ground. An impetus will be kept by the object until such time that the initial force is forgotten and the object returns to its natural state to stop moving and fall to the ground. One of Galileo's greatest contributions involved accurately measuring the effect of gravity on free-falling bodies. Galileo hypothesized that a falling object would gain equal amounts of velocity in equal amounts of time, which meant that its speed increased at a constant rate as it fell. Example: When you shoot a ball in a basketball ring, the ball does not need a force to keep it moving. Difference between Aristotle and Galileo's concept of projectile motion. Aristotle's view of projectile motion was based on natural tendencies and elemental properties, while Galileo's view introduced a more quantitative and empirical approach, emphasizing the role of gravity and mathematics in understanding projectile trajectories. 1. In all three cases, which object reaches the ground first? The book reaches the ground first because it is heavier compared to the flat sheet of paper in case 1. In case 2, both objects reach the ground at the same time, as well as case 3. To dot in activity 1, what causes the flat sheet of paper to move sideways? The force of the air on the paper is significant in its motion downward because of air resistance or air friction causing it to move sideways. 3 dot in activities 2 and 3. Why did the objects fall at the same time, or rate regardless of their masses? The friction on air or air resistance is insignificant. That's why the objects in activities 2 and 3 fell or reached the ground at the same rate. This is because the significant force causing the acceleration downward is the force of gravity. Whose view is more acceptable? Why? Galileo's perspective is more widely accepted because, according to him, objects that are dropped at the same time, regardless of their masses, will reach the ground at the same time when there is minimal or no air resistance. Consequently, falling objects experience uniform acceleration and are not influenced by their weight, but rather by the duration of their fall, the absence of air resistance,